this morning we're going to talk about proving triangles congruent using two new postulates or theorems, ASA and AAS. Cody, what do you think ASA stands for? Angle, side, angle. That's correct. Hannah, what do you think AAS stands for? Oh, I get it. AAS. No. ASA stands for angle, side, angle. Say again. Who was helping her? What did you say, Emily? Angle, angle, side. That's correct. So we're going to talk about proving triangles congruent using angle, side, angle, and angle, angle, side. And that goes along with what we already know, which is what? What are the two we already know? What's SSS stand for?
Side, side, side.
Side, 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 and SAS, which stands for side, angle, side. That's correct. Okay, moving on. The angle, side, angle postulate. Angle, side, angle postulate says if two angles in the included side of one triangle, right, please, are congruent to two angles in the included side of another triangle, then the two triangles are congruent. You could emphasize that a little stronger by saying the triangles must be congruent. When we talked about side angle side, what did we say was most important about the significance of the S, A, and S in that order? Very good, Nick. It's the side and then the two sides and then the angle between them. That's exactly right. That's the significance of that. And so what do you think the significance of this ASA stands for?
There's like two angles in this.
There's two angles and the side has to be where? In between them. They have to be in order. An angle, and then that adjoining side, and then the next adjoining angle. So when we look at this picture right here, we have this angle right here, and then we have this side, and then we have this angle. Is that side connecting the two angles together? That's the way it has to be. It has to be the side that's connecting the two angles that you're looking at. Okay? So we have angle, side, angle, both these triangles. Angle, angle, side, and angle. Okay? Now, you can just set your pencil down. You don't have this slide. I want you to watch for a second. What I've done is I've copied this segment to be exactly the same as that one. Do you agree? Okay. And I've copied this angle to be exactly the same as this one. Do you agree with that? And I copied this angle here to be exactly the same as this one. Do you agree with me? So we have here two congruent angles and a congruent side, right? And if I build a triangle, we'll start with this one over here. I start with this angle right here. And I put this side on there, and you'll notice I'll put that right to the end of that. See there what I did? I took this side and I put it right up to the end of that angle, so right in the vertex of that angle. Then I'm going to do the same thing with this, except I got my finger in the way and I can't see it, so I'll switch. Okay? So, what we we have there is that black side connected those two angles, didn't it? Okay? Now we don't quite have an angle or a triangle there, do we? But if I took this and extended it out here, and I drew another one here,
Yeah, eventually meet.
shadows. So I have that. Do you agree I have a triangle there now?
Yeah.
Okay. And if I built this one over here the same way, I'm going to start with this angle just like I did over there. I'm going to put this side on there so that it goes right to the vertex. And I'm going to put this angle on there so it goes right to the vertex to the end of that side, so it looks like that. And then I'm going to draw out the rest of these sides so that didn't mean to do that. So we have something like that. Okay? Now, let's try this. If I go highlighter. Try that again. I thought it would snap on like it. And look at that. If I put this up here, do you agree that they're exactly the same? Do you agree with that? Okay. So what we're getting at is we can construct, and we just did that, we constructed congruent triangles using angle side angle. Okay? Now we could use it, we could do this and use our compass and copy angles and do all that, just like we did earlier when we did a unit on constructions. I'm not so concerned that you have the ability to do the construction, just I want you to see that given those three facts, two angles and the side between them, is enough information to prove these triangles have to be exactly the same when I build them are equal parts. Okay? All right, let's move on to what you do have on your paper. Angle, side, angle. I guess if you're watching this at home, you would have not tried to copy all that down on that last slide. You just would have watched it with the rest of us. So, angle, angle, side. If two angles in the non-included side of one triangle are congruent to two angles in a non-included side of another triangle, then that's enough information to know the two triangles must be congruent. Two angles in a non-included side of one triangle are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. Sorry. I have to say that again because I forgot to press record again. So the question here is, are these triangles congruent by AAS? And there's 4 triangles, but we'll just focus on the first 2 here. Triangle ABC and triangle FED, and I didn't put them in the right order. I just was calling them by their individual triangles, not trying to say they're congruent. So, are they congruent?
Yes.
Well, you say yes. Let's look at the pieces. We have to go angle, angle, side, right? Okay? So if I start right here, and I go this way around, I have an angle here, but then I don't have that next angle, do I? No. So I can't do that. All right? So if I start here and go this way around, I have this angle, and then I have the next angle, don't I? Yes. And then I have the very next side, don't I? And so I went from 2 marks to the angle with 1 mark to the side with 1 mark. Let's go over here if we can do the same thing, see if it works. We start with this angle with 2 marks, this angle with 1 mark, and then the side with 1 mark. Do we agree that they're in the same order?
Yes.
So that's enough information then to say those 2 triangles are congruent by angle, angle, side. Now they're going to ask you to write a congruent statement. Phoenix, you with me? They're going to ask you to write a congruent statement. So, let's write a congruent statement. Triangle. Someone give me the first triangle. ABC. Triangle ABC. Now, when we line this up with the next one, we have to match up what kinds of parts? What is that C word? What kinds of parts do we match up? We have to match them up in what order? Corresponding. Very good. Was that you, Kaylee? Nice job. Corresponding order. So, we went, move these out of the way here. We went triangle ABC. So we said 1 mark, 2 marks, and no mark, right? So we have to do the same thing with the other one. So where's the 1 mark? D, 2 mark, E, and the no mark, F. Don't just go alphabetical. They'll trip you up if you try to go alphabetical all the time. I know ABC, then D, E, F. That's the right order alphabetically, but it may not be the right order when you look at the parts. Okay, let's look at these 2. Are they congruent by angle, angle, side? Are they congruent by angle, angle, side? Nope. What do you think, Jaden?
Which one?
The bottom 2. The only 2 actually you can see on the screen right now. Are they congruent by angle, angle, side? Simple question. Yes or no is the answer. 50-50 chance.
What if I get it wrong?
Probably have to lose your little bun on top of your hair there, but that's okay.
Looks like a croissant.
It does kind of look like a croissant. Very cool. I've never seen that look with you before. It looks good. All right, come on. Yes or no? Chop, chop. Yes, she says. Okay. And Paul has drastically said no 3 times. Melody. What do you think? Yes, she says. Nick, what do you think? Your hands are flailing back there. Yes or no? Do you believe Jade and Melody, or do you believe Paul?
I'm gonna go with no.
Not guilty?
No, I did not. No.
Not congruent. Okay. I should say not congruent by AAS. It could be still congruent, couldn't it? Okay, let's look at it. Isn't this an angle? And then another angle, and then the very next side? Isn't this an angle, and another angle, and the very next side?
Yes, but they're not.
Doesn't that appear to be angle, angle, side?
No.
But it's
Yes.
Clear.
Yes, it does.
Oh.
It's the same order.
Okay, slow down. It does appear that way at first glance, doesn't it? But, Nick, neat Nick there, explain to me why you feel so strongly the answer's still no.
that triangle flipped.
That triangle flipped, what do you mean by it?
It's upside down and rotated to the left.
Well, that's not a problem. I can rotate it around, flip it around.
If you look at the side, E and D, that's not the
Segment
side.
ED,
That's not the side of BC.
it's not the side of BC.
What are you talking about?
And they're definitely not drawn to scale, right? Do you agree they're definitely not drawn to scale?
Yeah, but it doesn't make any sense though. If you're to turn it, it would not be congruent.
Okay. Emily, you look like you would like to say something.
I think I kind of get what he's saying. Instead of starting with F, you'd start with D, and then it doesn't make sense on that side. 'Cause
Oh. So So what you're saying is, instead of just focusing on angle, then an angle on the side, I should have been focusing on an angle with 1 mark, an angle with 2 marks, and then the side, right? If I go over here, an angle with 1 mark, then the angle with 2 marks, I don't have that very next side, do I?
Yes.
Ah, so that's kind of tricky because, yes, I have 2 angles then a side, but I don't have the corresponding angles then the next side, do I? So we have to be a little bit careful with that. Okay?
I want to prove that.
Very good. The answer is truly no. All right?
What if I wanted to
Okay, moving on.
no?
What else must you know to prove the triangles congruent for the reasons shown? And there's 2 of them here. And they want us to show that it's congruent by angle, side, angle. So before we actually ask this question, let me ask this question instead. Megan, I think you can answer this. In these 2 triangles, what do I already know? Now, I don't know angle, side, angle. Which angles? What's that? The vertical angles. Very good, Alexis. What are the names of those vertical angles? LN is a segment. Which I agree. They put this mark here, meaning we already know this is equal to this. Because they have matching marks. So one of the things we already know about this picture is the segment LN is congruent to segment PN. Right? And then you told me we have vertical angles here, which I agree. Pretty sharp looking bow tie. We have those vertical angles. How do I name those vertical angles?
We're okay.
I guess.
This is working now, right?
Sorry, I don't know what happened there. My shirt got something in there. I think I deleted that page by mistake. Anyway, we're back. How do I name them, Paul?
MNL and QNP.
So angle,
Angle
MNL is congruent to angle
Q
and P. I agree with that. Very good. So we already know that. And so they want us to use angle, side, angle. So what's the significance with angle, side, angle? What's important to know about angle, side, angle? That, louder, Brandon? That the side is in between the 2 angles. So if I have this angle on this side, and I have this angle on this side, what's the other angle I have to have? This is answering this question now. What else must I know in this picture? Because the way the picture's drawn, I already know this, and I already know this. So what else do I need to know? L, angle L.
L is an angle.
Yep.
And then
Okay. So what you're saying is what I need to know to answer my question is that angle L is congruent to angle P. That's what I need to know. So that's how we answer that question. Okay? So when they ask you a question like this and they say, what else do I need to know? Phoenix, are you with us?
L. Temple Jr.
What's over there?
Gandhi.
We're up here, man. You copy this down yet? Okay. Except probably the answer. I'm pretty sure you
It's your
didn't
boy,
write that down yet.
Fifi.
Now, understand when they ask you this question, there's only one fact that you are looking for. The other two are given to you. It may not be written out, but they're given to you. They're in the picture somewhere. And so when we go down to this one, by angle, side. At first glance, Melody, at first glance, how many facts does it look like they gave us in these two triangles? Really? Ah, so you jumped right to that fact, didn't you? She said, if you didn't hear it at home, that segment BD is the same in both triangles. So we could say segment BD is congruent to segment BD. That's one of the things they gave us already, right? What's the other fact they gave us, Catherine? Marked in red. Yep, they gave me two angles. Can you name them? You have to use three letters because there's too many angles there at point B. Can't use single letter. Louder, Mackenzie.
Is it angle B80?
BAD is this angle.
Yeah. So it's BC.
But I'm asking, what angle did they give you already? They didn't mark this, so we don't have this angle here. We don't know what that is. Angle AB, ABD is congruent to angle CBD. Those are that's the fact they gave us. That one right there is congruent to this one here. Okay? Now in this question they're asking you to identify what else would we have to know to say these triangles are congruent by angle, side. And I know angle ABD congruent to angle CBD, and I know segment BD congruent to segment BD. So where would that other angle have to be?
It's on JFK, but I didn't choose.
I don't think it's JFK. I think JFK was a former president.
Oh, no wonder I got that mixed.
Yeah.
It wasn't meant
B,
BAD
and BCD.
He said it would be angle BAD, the bad angle, and angle BCD, that angle. Do I have to use three letters to name them? No. Why not this time? What could I call angle BAD instead of angle BAD? Angle, what? Angle A. Angle A. It's the only angle at point A, isn't it?
Yeah.
So we can just call this angle A, and we would have to know it's congruent to angle C. I feel like some of you are confused, Jack, as to why I had to use three letters here, and I only need one there. If we look at point A, hopefully you agree this is the only angle at point A. If we look at point C, this is the only angle at point C. But at point B, we have this angle, we have this angle, and we have this angle. There's three angles up there at point B. If I just called it angle B, then I wouldn't know which one I was talking about. Okay? So when there's more than one angle there, you have to use either numbers, if they've numbered them for you, or three letters. Okay? Any questions on that? All right. Now, your homework 1 through 21 all can be confusing. There's some different kinds of questions there. I did not do every single example. They've got some developing proof questions where they've got a paragraph style proof written, and then they've got a couple blanks, and you have to fill in the blanks. Bless you. When you do that, look at what's given to you. Look at the picture. Okay? Think about all the things we've talked about. Reflexive property means what? What's reflexive property mean? What's that? Something equal to itself. Good job, Brandon. Reflexive means something's equal to itself. And then look for vertical angles, look for all the other little things that we've done, okay? Try it, work on it together, talk it out in your groups. If nobody in your group has a clue, let me know and I'll come over and try to lead you in the right direction.
Yeah, girl, man.